हेलो एवरीवन, हाउ आर यू ऑल? क्या हाल चाल हैं? वेलकम ऑल ऑफ यू। गुड मॉर्निंग ऑल। गुड मॉर्निंग एवरीवन। गुड मॉर्निंग, गुड मॉर्निंग। Okay, so few students are regular in class always. Nice to see that. Okay, no issue. So here, first of all, you can see this is my profile. I have been teaching for more than 10 years for different competitive exams, CSE, SE, GATE and PSU. So notes and whatever information about the contract I am always sharing in this free Telegram group. This is the free group, you all can join. Okay, and if you want to join the paid courses, so just message me on the Telegram on this number. That's it. By that you can join the paid courses. Okay, chaliye. So we are learning here now complete course of engineering mechanics. We are learning here the complete course of engineering mechanics, okay, for all the branches. And today's topic is linear momentum and impulse and collision. Okay, so today we will start this topic. Up to this we have done. Okay, up to this we have done. So today we are starting the next topic, linear momentum conservation, impulse and collision. Okay, impact and collision. Okay, so write down heading, linear momentum and linear momentum conservation. Linear momentum and linear momentum conservation. Momentum conservation. Okay, so first of all we will see the linear momentum. What is the linear momentum? Linear momentum. Okay, write down the heading, linear momentum. So generally we denote the linear momentum by P. Okay, P like this. Okay, so write down here, it is a vector physical quantity. It is a vector physical quantity given by the effect of mass and velocity of the body. Mass and velocity of the body or system. Okay, so when there will be a single body, then what will be the linear momentum of that single body like this? Let's say this is a body of mass m, and at any instant it is moving with velocity v like this. It is in linear motion and it is moving with velocity v like this. Okay, so in that case, what will be the linear momentum of this body? So it will be equal to m into v. So this will be your dot product or क्रॉस प्रोडक्ट. कौन सा प्रोडक्ट ये होगा? m इंटू वी आप कर रहे हैं. इट विल बी डॉट प्रोडक्ट और क्रॉस प्रोडक्ट. बोलो बोलो. It will be dot product or cross product. m into v. Neither dot nor cross product, because m is scalar. Yes or no? M is your scalar and v is your vector. Yes or no? V is vector. So one is scalar, one is vector. There will be simple multiplication, neither dot nor cross, because dot and cross product are there between two vectors. So this will be actually simple multiplication, no dot, no cross. Okay, dot and cross will not be there. So in magnitude form, we can directly write that P will be equal to m into V. P equal to m into V in magnitude form. Here the direction of V will be the direction of P. So the vector P will be always in the direction of velocity, because mass has no direction. So whatever the direction of velocity will become direction of the linear momentum. Okay. So when you will consider the velocity in x direction, linear momentum will be found in x direction. When you will consider velocity in y direction, then linear momentum will be found in y direction, like this. Yes or no? When you will consider velocity in z direction, then linear momentum will be in z direction, because whatever the direction of the velocity will become the direction of linear momentum, because mass having no direction. Clear or not? Mass having no direction, it is scalar. Good morning, good morning. Okay, mass is scalar. So for single body you can simply find the linear momentum. इसका mass into velocity कर दो, then vector P will be your linear momentum in the direction of velocity. Very simple. But for a system of masses or system of particle, let's say if there is system of particles, when there is system of particles is there, then how to find linear momentum of the system? Here we will see the velocity of what? Center of mass of the body. Center of mass of the body. Velocity of center of mass. Velocity of body means center of mass ka velocity. Similarly, when you are considering the system of particle, let's say many particles are there. Let's say many particles are there. This is particle 1, this is particle 2, okay, this is particle 3, like this. Many particles are there, means it is system of particles. So how we can find the linear momentum of this system? So simply first thing what you will do, you will consider like axes x and y here. Let's say all particles are lying in the same plane. Okay, let's say on table. Okay, so this is the particle 1. Its mass is, let's say, m1. Its mass is, let's say, m2. Its mass is, let's say, m3. So here this particle position right now, its center of mass will be C1. Its center of mass will be, let's say, C1. Position is x1 comma y1. Its center of mass is at C2. Position is x2 comma y2. Its center of mass is, let's say, C3. Position is x3 y3, like this. This you will consider, and this is our system which we are going to study. This will be our system. For this system we want to find the linear momentum. Okay. Now particle 1, let's say, at this instant is going with v1 velocity, like this. v1 velocity is there, like this. Particle 2 is going, let's say, with v2 velocity, like this. Particle 3 is, let's say, going in this direction, v3 velocity, like this. Okay, so they will be going like this. and let's say these velocities are making angle, these velocities are making angles, okay, some angle they will be forming. Let's say ये x axis से theta बना रहा है, this is making from x axis beta, this is making from x axis gamma, like this. So you can simply write down these velocity in form of vectors, okay. So v1x, v2x, that will be known, okay. So now here how you will find the position of center of mass of the body. So let's say center of mass of the body will be here, and its coordinate will be x bar comma y bar, x bar comma y bar. So how we can find the position of the center of mass of this system? So first you will write the x bar. X bar will be how much? m1 x1 m2 x2, like this. You will add all the masses, then upon m1 plus m2, like this. You will add all the masses like this. So you will find the value of x bar. Here also you can find the value of y bar, m1 y1 m2 y2. ऐसे ही तो find करते थे. Already we have done this in center of mass chapter. Yes or no? Yes. So our first work is complete. We can find the center of mass of the system like this if they ask you. If they ask you. Now you have to see what is the velocity of this system at the center of mass. So velocity of center of mass of the system you have to consider. Yes or no? Okay. So velocity of center of mass of the system will be given by velocity of center of mass in x direction plus velocity of center of mass in y direction. This will be the complete velocity vector of the center of mass of the system. Clear? Now, here how we will find x component of the velocity of center of mass. X component of the velocity of center of mass. So it will be given by actually dx bar by dt. X bar is what? m1 x1. So here the total differentiation will be like this, because mass is constant. Mass is constant. So these x term will get differentiate. These x term will get differentiate like this. Yes or no? Yes. So simply you will differentiate these, you will get the x component of that. So simply it will be how much? It will be equal to m1 v1x. This term will become v1x, m2 v2x, like this. And here m1 plus m2 and all these things. Next, similarly, you can find the y component of velocity of the center of mass. m1 v1y, m2 v2y, like this. Yes or no? So this will be the case. m1 plus m2 plus, like this. So this will be, so this will be your third and this will be your fourth part or equation. So by these two, when you will put here, you will get the total velocity of center of mass. Total velocity of center of mass. Yes or no? Similarly, if they ask you sometime acceleration of the center of mass, So acceleration of center of mass in x direction will be what? That you can understand now. Again you will differentiate, so it will be m1 a1x, m2 a2x, like this, over total m1 plus m2 dash dash. And center of mass acceleration in y direction, it will be m1 a1y, m2 a2y. So this will be your acceleration of center of mass of the system. If somewhere this will be needed, we can also find the acceleration. So the total acceleration will be how much? Total acceleration of the center of mass. It will be acceleration of center of mass in x direction plus acceleration of center of mass in y direction, like this. So total acceleration you can also find like this. Okay, that's it. Now how much will be the total external force on the system? Here you can find total net external force on the system. So total force will be equal to what? Total mass into acceleration of center of mass. Acceleration of center of mass of the system. Yes or no? Center of mass of the system. Okay. Now linear momentum, you know, it is given by m into v. M into v. So here linear momentum of the first particle will be what? P1 equal to m1 v1, P2 equals to m2 v2, like this. So linear momentum will be like this. Okay. Now how you will find the linear momentum of the system? Because all these are different vectors. All these are different vectors. So net resultant of these vector will be the linear momentum of the system. So vectorial sum you will do. You will not directly add. This is vectorial sum. Vectorial sum you will do. Let's say n number of particles are there. So total linear momentum will be like this. Clear or not? Very good. So here this is the total linear momentum, like this. So this is vectorial sum, Clear? And it is also given by the linear momentum of whole system, mass into velocity of center of mass of the system. This will be also given like this. Okay. Now linear momentum we have understood. Linear momentum. For a single body, simply multiply mass into velocity. For a system of masses, you have to add all the linear momentum vectorially. Okay, so this is vector sum. This is not direct algebraic sum. This is vector addition. This is vector addition, not direct addition. This is vector addition actually. Yes or no? Because all are vectors. So net resultant will be found by vector addition, not by direct addition. Clear? Now what will be the linear momentum conservation? So now write down heading linear momentum conservation. Linear momentum conservation, or you can say principle. Linear momentum conservation principle, LMCP, linear momentum conservation principle, LMCP. Write down here, if net external force on any body or system on any body or system will be equal to 0, then its linear momentum will remain constant or conserved, will remain constant or conserved. Okay, clear? So when any body or system जिसका नेट एक्सटर्नल फोर्स अगर उस पर 0 होगा तो उसका लीनियर मोमेंटम विल रिमेन कंजर्व. ओके, सो नाउ as we know if mass of the system or body is constant, then net external force is how much? Net external force is how much? It is equal to m into acceleration of the center of mass. M into acceleration of the center of mass. Let's say net external force is 0. Okay, then this term will be 0. So इसलिए acceleration of center of mass will become 0. इसलिए velocity of center of mass will become constant. Yes or no? Acceleration 0 है means velocity will be constant. Okay, and mass was already constant. Mass is already constant. Yes or no? So mass and velocity both are constant, hence linear momentum P equal to m into v will become constant और कंजर्व. ये कंजर्व हो जाएगा, कांस्टेंट हो जाएगा. Got the point or not? So what we can write? If somehow velocity will be decreasing, then mass will be increasing. So for simple case we have find the relation. Simple case is mass is constant. We found this relation. Now in any general case, if mass will be increasing and no force is there, velocity will be decreasing. If mass will be decreasing, velocity will be increasing. Okay, so now we got this relation, beautiful relation by simple procedure. Now we can apply in any general system. Now it is applicable. Now it is applicable for all system. Okay, so if net external force is 0, if net external force is 0, then when mass will increase, velocity will decrease, and when mass will decrease, velocity will increase, like this. ऐसा होगा. Okay, means m into v will be constant. So let's say mass increase होके हो जाता है m1 v1, or you can say in different condition the p equal to m into v will be m1 v1 equal to m2 v2, like this. Mathematically you can write like this, है ना. मास अगर इंक्रीज होके m1 हो गया, देन वेलोसिटी बाय डिक्रीजिंग विल बिकम v1. ओके, सो हियर इफ m1 इज मोर देन m, v1 will be less than v. Here if m2 is less than m, then v2 will be more than v. Got the point or not? So if mass will increase, velocity will decrease. If velocity will decrease, then mass will increase, like this. So if there is no net external force, its linear momentum of the system will remain constant or conserved. Clear everyone? यहाँ तक सभी को क्लियर हुआ? बोलो. Everyone clear up to this? Very good. So this is for a single body, है ना? For the system, of masses, let's say there is two mass system. Let's say there is two mass system like this. One particle is this, second particle is this. Okay. So if we are considering two mass system and there is no external force, okay, then let's say this is mass m1, this is mass m2. Initially they are moving with u1 and u2. If something will happen without external force, okay, then we can write here, if net external force is equal to 0, the linear momentum of system will remain conserved. Linear momentum of the system will remain conserved or constant. Okay, means change in linear momentum of the system will be 0. Means the final linear momentum of the system minus initial linear momentum of the system will be equal to 0. Means the final linear momentum of the system will be equal to initial linear momentum of the system. Okay, or I write here initial, here final. So let's say these are two masses. Initial velocity is v1 and v2 and final velocities are, let's say, v1 and v2 without any external force. Something happening inside the system. Let's say they are doing collision. So that due to that collision, some internal force will be there, but there will not be any external force. So in that case, the linear momentum of system will remain conserved. Okay. So initial linear momentum will be what? It will be sum of linear momentum of both the bodies, like m1 u1 plus m2 u2, okay, equal to final linear momentum will be what? m1 v1 plus m2 v2, like this. Okay, m1 v1 plus m2 v2 like this. So this will be our total equation. So if we write in general term, m1 u1 plus m2 u2 will be equal to m1 v1 plus m2 v2. Here velocities must be taken with sign. So this is equation of what? Linear momentum conservation equation for the system. Here velocities must be taken with sign as per their directions. Okay, ये ध्यान रखना है. We have to remember this. So if u1 will be right side, it will be positive. If u2 is left side, it will be negative. If v1 is right side, it will be positive. If v2 is also right side, then it will be positive. So here velocities must be placed with sign because they are vector. Clear or not? So these terms are actually vectors. So there is vectorial sum. Vectorial sum of the linear momentum. Linear momentum is a vector physical quantity. We cannot directly add or directly subtract. Everyone clear up to this? जिसको यहां तक क्लियर हो गया वो जय हिंद लिखो एकदम से। चमक रहा है? चमका कि नहीं चमका? चमका कि नहीं चमका? वेरी गुड। नोट कर दो यहां तक। आई एम जस्ट कमिंग बैक इन 2 minutes। Okay, all done up to this? Very good। आगे बढ़ा जाए? आगे बढ़ते हैं। लेट्स मूव फर्दर, लेट्स मूव फर्दर। नाउ राइट डाउन हेडिंग इम्पल्स एंड मोमेंटम मेथड। इम्पल्स एंड मोमेंटम। या पहले हेडिंग डालो इम्पल्स एंड मोमेंटम मेथड, ऐसे ही लिख दो। चलो impulse and momentum approach or method। So in this, what is impulse? What is impulse? So impulse is given by I actually, and it is also a vector quantity। Okay, so write down here, write down here, when force acts on a body or system for a short interval of time, for a short interval of time called impulse, called impulse। Okay, so impulse will be given by I equals to f into very small time, let's say dt, very small time, let's say dt। So f into dt will become your impulse। Okay, if this is dt, let's say first write delta t, so here delta t will be very small, delta t will be very small। Now impulse will be equal to when limit delta t will be tending to 0, tending to 0, then it will become f into delta t, it will become f into dt। So in case of this, we will consider the impulse by f dot dt integral from time t1 to t2, from time t1 to t2. So these are the formula of impulse. These are the formula of impulse. So what will be the unit of impulse? Newton second. This will be the unit. Yes or no? Either this formula direct, if this formula direct. Here force can be constant or not. It is not necessary that force will be constant. Okay. Here force can be as function of time. फॉर एग्जाम्पल जैसे आपको दे दिया जाए 2t² + 3t + 8 like this. Force can be given you like this. Okay, this is second equation, let's say. Third equation, let's say. So here force can be function of time like this. So simply you will put the function here in this equation here and integrate it from time t1 to t2. If time is also given to you that it is acting from this time to this time, that's it. Simple. So you can like this find the value of impulse. So impulse is the force which acts for short interval of time like this. Okay, so this is an impulse. Now what is impulse and momentum method? What is impulse and momentum method? So write down here, impulse is also given by, is also equal to the change of momentum. Change of momentum. Okay, so here it will be better if you use the linear word. Linear word here. Use the linear word here. Linear impulse and linear momentum. Linear impulse, because impulse can be also angular and momentum can be also angular. Okay, change of linear momentum like this. Okay, that we can prove. That we can prove. Let's say there is a body. एक body है इस तरीके से. There is a body like this, है ना? Block is like this. Initially this block is moving with, let's say, constant velocity u, है ना? Surface is perfectly smooth, so no friction, nothing is there. No friction, nothing is there, and it was initially, let's say, moving with some initial velocity u like this, like this. Okay, so initially it is having velocity u like this at this position, at this position. Okay, now when it reach at this position, we start applying a force. We start applying a force, let's say like this. When we start applying a force F here, what will happen? What will happen? Let's say mass of this block is constant, force is applied, so it will gain some acceleration. Yes or no? It will gain some acceleration. So from position 1 to 2, what will happen? The velocity of body will get changed. From here to here, when it will go, the velocity of the body will get changed. Here it will have, let's say, v velocity, because force is continuously acting. So here velocity will be continuously increasing. Here, let's say, its linear momentum will be what? P initial. Okay, here its linear momentum will be what? P final. So its linear momentum will get changed. Its linear momentum will get changed. What we can write here? You can write here, let's say, You are applying the force F. Mass is constant, so you can write ma. M you can write what? M into A you can write what? dv by dt. So this you can write like this: F into dt equals to m into dv. Okay, so if you will integrate from this, from time t1 to t2, from time t1 to t2 like this, and here integration will be from u to v like this. Okay, so your left side will become impulse. Actually an impulse will be linear impulse. Impulse will be equal to linear impulse. Okay, so this linear impulse will be equal to the force into dt from time t1 to t2 equal to m. this term will become what? m इंटीग्रेशन करेंगे तो v माइनस u आपको मिलेगा. यस और so this you can write mb minus mu. So it will be mb minus mu means change in linear momentum, means p final minus p initial. So it will be equal to change in linear momentum like this. Okay, so now thing or statement is proved that linear impulse is equal to or given by the change in linear momentum. Yes or no? So this is the thing. So equation 3, this is equation 4. Linear momentum is equal to change in, sorry, linear impulse is equal to change in linear momentum. Okay, now this integral, here everything is vector. Mind that this is also vector, force is also vector, this is vector, this is vector, all these quantities are vector. Okay, now here they can give you the variation of force. They can give you the variation of force with respect to time. Sometime they will give you equation of force. So equation of force you can directly solve by integration, but sometimes they will give you the graph of force and time, means variation of force with respect to time. So force will be varying like this. Let's say between time t1 to t2 force is varying like this. Between time t1 to t2 force is varying like this. Okay, this is time t1 and this is time t2. So the area under curve will give you the value of integral. Area under curve will give you the value of integral t1 to t2 f into dt. So it will be also equal to the change in linear momentum. Okay, so it will be also equal to change in linear momentum or linear impulse. So this is your equation number 5. So either you can find the linear impulse by change in linear momentum, or you can find it by integration, or you can find it by the area under force time curve. Area under force time curve. सभी को क्लियर हुआ हो गया यहाँ तक? बोलो. तो जय हिंद लिख दो फटाफट. Write down जय हिंद here. If up to this everything is clear, write down Jai Hind in the comment. ओहो माइक नहीं लगाया. Correct. Yeah. Human errors are there. Now it is fine. Jai Hind, Jai Hind, Jai Hind. माइक लगाना भूल गए. पढ़ाई में हम लोग इतना रम जाते हैं, है ना, दुनियादारी सब भूल जाते हैं. हाँ, वेरी गुड. So this method is called your impulse and momentum method. Okay, now write down heading. All this we have done. Now write down heading impact and collision. Now write down heading impact and collision. Impact and collision. So that was impulse and this is impact. Okay. So write down here what is impact and collision. When any two elastic bodies, so every real body is actually elastic body, है ना? We are not considering here rigid body. Generally in mechanics all bodies are rigid, air body will not be rigid. When any two elastic bodies, or you can say real bodies, initially moving with some velocities strike to each other. First they get deformed. And then try to regain original shape. Due to restoring elastic forces. Okay, and get separated with new velocities. Okay, during the contact, next paragraph, during the contact a large during the contact for short time, लिख दो, during the contact for short time, they will be in contact for short time, let's say delta t. A large force act on both the bodies equal and opposite called impact force. Okay, which is not constant during delta t time. During delta t time. Okay, so its average value is calculated. Okay, this whole phenomena is called collision. ये जो भी पूरा process हुआ, this process is called collision. The collision is the process in which impact is the force. Collision is the process of striking two body and get separated like this. Okay, So that is process, and impact is the force in that. Now what is the difference between impact and the impulse? Impact भी for short interval of time लग रहा है, कहाँ गया? Impact भी short interval of time के लिए लग रहा है, and impulse also act for short interval of time. What is the difference? What is the difference? Like you play the carom board, na? So in carom board, when you strike the striker like this as external agent, that is impulse. When external force is applied, you are not being collided with the striker. You can simply put your finger with the striker like this in contact initially and just push it. So it is not the impact. Okay, impact, if you keep your finger away from the striker and impact like this, then it will be impact. But if you put the finger with the striker and push it like this, it will be impulse. When this striker will go and hit the another body, so when there will be striking or collision of two body, then the force will be called impact force. So both are for short interval of time. Both value can be calculated by F into delta T, but the application is different. The feeling is different. Yes or no? That's why different names are given to them. Different names are given to them. Okay. So what is the full story here? Let's say this is the first body. Initially it is moving with some initial velocity u, let's say, and another body which is initially moving with another velocity, let's say u2. Okay, it is moving with u1 velocity and it is moving with u2 velocity. Okay, so both are in same direction. Here condition of a strike will be what? u1 is greater than u2. u1 is greater than u2, only then a strike will happen. So this is our system. हमको system भी मानना पड़ेगा. For what system we are talking about? This is our system. So when this first body will come and strike to a second body, initially what will happen? They get deformed. They get deformed at the point of contact. At the point of contact, they get deformed. So initially deformation will be there. Initially deformation will be there here. At the point of contact, deformation will be there. Okay, and this is our system. So when they are striking like this, a large impact force will act. So on the body 1, the force F1 will be left side. On the body 2, the force F2 will be right side. And they are in contact only for delta T time, for very short interval of time. Okay, so this F1 and F2 will be actually equal. Okay, so I am directly writing this as average force. Why this is average force? Because this force will not be constant during the contact. Initially they will come just in contact, so force will be 0, then force will become maximum, again the force will become 0. So this force will be actually variable force, it will not be the constant force. Let's say this is the force, this is the time. So this force will first increase, then decrease to 0. So there is variation of the force. So this is not constant force, that's why we calculate the average value. So this force will be actually average impact force. इसका नाम क्या होगा? This is called average impact force. This force is average impact force. Okay. Now finally the bodies will get separated. Finally the bodies will get separated like this, and let's say start moving with another velocities, new velocities. Let's say it is also going in positive direction and it is also going in positive direction. For simplicity, we are considering right side. Okay, so when direction will be right side, velocity will be considered positive, positive, positive. Okay, so this is our system. This is our system. This is our system. Okay, so here this force is actually internal force because both equal and opposite are inside the boundary. है ना, action and reaction. This is action, this is reaction. Both are inside the boundary. So this is internal force. Yes or no? So this average impact force will be actually internal force here. And internal force cannot change the state of system. So internal force is there. So net external force is 0. So here net external force will be actually 0. No external force is there. So we can conserve the linear momentum of the system. Yes or no? We can conserve the linear momentum of the system. So for whole system, we can apply the linear momentum conservation equation. Yes or no? We can apply the linear momentum conservation equation for whole system, not for a single body. For single body, its linear momentum is changing. Here linear momentum is m1u1, but finally linear momentum is m1v1. सेकेंड बॉडी के लिए भी इनिशियल लीनियर मोमेंटम इज m2u2 एंड फाइनल लीनियर मोमेंटम इज m2 into v2. So individual body linear momentum are getting changed, but for whole system linear momentum will remain same. Got the point? So apply first. As for the system, net external force is equal to 0. So apply linear momentum conservation equation. So linear momentum initial of the system will be equal to linear momentum final of the system. Okay, so initial linear momentum will be what? It will be equal to m1u1 plus m2u2 equal to m1v1 plus m2v2. Okay, so these are vectors actually. So here these velocity must be taken with sign. Either you write in vector form or you write like this m1u1 plus m2u2, what take the velocity with sign m1v1 plus m2v2. Here you have to consider velocities with sign. Always remember, consider velocities with sign or put the velocities with sign plus or minus as per their directions, So this will be like our first equation for impact and collision. So first equation is nothing but linear momentum conservation equation. इसको मैं यहाँ लिख देता हूँ यार, separate. Now it is fine. Okay. So for whole system linear momentum is conserved. Second चीज इसमें आपको पूछता है, that is called coefficient of restitution. coefficient of restitution, small e, स्मॉल ई। ओके, तो ये क्या होता है? सो पहली बात तो ये कि ई का वैल्यू जो होता है दैट इज बिटवीन 0 to 1, इट कैन नॉट बी मोर देन 1, इट कैन नॉट बी नेगेटिव। सो इट इज गिवन बाय द रेशियो क्या होता है? relative velocity after impact over relative velocity before impact। Okay, with a minus sign, but its value is not negative, because when you will solve these two things you will get a negative value. So negative into negative will become positive, so it will be equal to relative velocity after strike will be v2 minus v1, and relative velocity before strike will be u2 minus u1. So this you can write like this, v1 minus v2 or u2 minus u1, or you can write it v2 minus v1 or u1 minus u2. Okay, ultimately you have to take the positive sign. Okay, because e cannot be negative, because e cannot be negative, it is a positive value. Okay, now for perfectly elastic collision, फॉर परफेक्टली इलास्टिक कोलिजन ई का वैल्यू कितना होता है? 1। फॉर परफेक्टली इनइलास्टिक कोलिजन ई का वैल्यू कितना रहता है? 0। फॉर neither perfectly elastic nor perfectly inelastic, so you can call it partially elastic or partially inelastic. Okay, so partially elastic or partially inelastic collision, or you can say real collision, क्योंकि real collision partial ही रहता है ना। these two are not real collision, these are ideal case, these are ideal cases। perfectly elastic और inelastic कोई बॉडी नहीं होता है। एक्चुअल में बॉडी कैसा होता है? एक्चुअल में all bodies are real bodies, so these will be your partially elastic or inelastic collision. Clear? So here E will be less than 1 and more than 0. So between 0 to 1 value of E will vary like this. Everyone clear? So real collision is this. Perfectly elastic and inelastic are ideal cases. Okay, they will be taken only when it is given in the question. Okay, for real collision, for example, आपको दिया होगा अगर E का वैल्यू जैसे 0.4 दे दिया जाए, ओके, और 0.6 दे दिया जाए, लाइक दिस। सो these will be the cases for real collision. Really it will vary between 0 to 1. 0 to 1. Next, what they ask in this third thing, they will ask you about average impact force का value of average impact force. So how you will calculate the value of average impact force? Average impact force. So as we know, force is given by rate of change of linear momentum. Okay, so your average force you can calculate by total change in linear momentum over total time. Okay, so you can find it by P final minus P initial. Okay, P final minus P initial. So either you can find it by first body or second body. Either you will apply for the first body, final of first and initial of the first, or you can find it by final of second body and initial linear momentum of second body. ऐसा नहीं करना है इनिशियल किसी बॉडी का ले लिया, फाइनल किसी बॉडी का ले लिया. So either from first body or second body you can calculate the value of force. Okay, both forces will be just equal and opposite. Magnitude wise they will be equal. Magnitude wise they will be equal. If by first body you are getting minus 100 in this direction, then on second body you will get plus 100 in this direction. Magnitude will remain same, but sign will be opposite. If you will calculate by this, then let's say it is minus 100. When you will calculate by this, it will be plus 100, because forces will be in different direction on both the bodies. So magnitude will be same, but direction will be different. Next, change in kinetic energy they can ask you. और क्या पूछ सकते हैं इसमें? Change in value of kinetic energy of the system. Okay, so for whole system kinetic change in kinetic energy of the system will be equal to final kinetic energy of the system, kinetic energy of the system final minus kinetic energy of the system initial. So what will be the value of change in kinetic energy of the system? Final will be half m1 v1 square plus half m2 v2 square. Okay, these are the final velocities, so final kinetic energy, and these are initial velocities, so these are initial kinetic energies. So we will add like this. So this will be the change. Okay, now if E equals to 1, change in kinetic energy of the system will be 0. If E is not equal to 1, then change in kinetic energy of the system will not be 0. Okay, तो अगर परफेक्टली इलास्टिक कोलिजन होता है तो बॉडी जितना डिफॉर्म होगा उतना रीगेन हो जाएगा. देयर विल बी नो लॉस ऑफ एनर्जी, okay, so this is the case. So E equal to 1 and no friction, nothing else, no friction etc. Air friction नहीं होगा, even then your kinetic energy will not conserve, because deformation can be there, bodies are elastic. Okay, so generally we don't consider friction here in case of impact and collision. Clear हुआ सभी को? Everyone clear up to this? तो जय हिंद लिख दो फटाफट. Definition of impulse and acceleration is same. किसने बोला? Definition of impulse and acceleration is same. Who told you? What is the definition of acceleration and impulse? Impulse is the force which act for short interval of time. इसमें acceleration कहाँ से आ गया? Acceleration क्या definition बताया था? Acceleration is defined as rate of change of velocity. कैसे डेफिनेशन सेम हो गया अपने मन से? कुछ भी बोलने लग जाते हो आप लोग। हाँ, ऐसे नहीं किया करो। चलिए, नाउ लेट अस कंसीडर स्पेशल केसेस। स्पेशल केसेस, so let us consider special cases. Special cases, so case 1, just 1 second. Case 1, hello. Case 1, case 1, if we are considering perfectly elastic collision E equal to 1 and mass of both the bodies are also same, mass of bodies are also same, what will happen? What will happen in this case? Velocities will be exchanged. Velocities will be exchange. Velocity exchange हो जाएगा. फर्स्ट बॉडी का वेलोसिटी सेकंड को मिल जाएगा, सेकंड बॉडी का वेलोसिटी फर्स्ट को मिल जाएगा. नाउ चेक हाउ. फर्स्ट यू अप्लाई लीनियर मोमेंटम कंजर्वेशन इक्वेशन. लीनियर मोमेंटम कंजर्वेशन इक्वेशन. लेट्स से m1 u1 first of all mass will cancel out because mass is constant. Mass are equal, so they will cancel out. Now u1 plus u2 will be equal to v1 plus v2 will be first equation. Now you will apply second, coefficient of restitution. Coefficient of restitution, so it is defined as minus of v2 minus v1 over u2 minus u1, like this. So from here what you will get? v1 minus v2 over u2 minus u1. मल्टीप्लाई कर दो इधर, so ये हो जाएगा u2 minus u1 equal to v1 minus v2. Okay, now add both these equations. Add 1 and 2. Add 1 and 2. So u1 will be cancelled. 2u2 equals to v2 cancelled, 2v1. So actually final velocity of first body will be equal to initial velocity of second body. And when you will put in the equation once again, you will get v2 equals to u1. मतलब क्या हुआ? What is happening? The velocity of second body is given to first and velocity of first body is given to second. So velocities are exchanged. Velocities are exchanged. Yes or no? Simple. Velocity पहले का दूसरे को मिल जाएगा, दूसरे का पहले को मिल जाएगा. Velocities will be exchanged. That's it. Okay, so this is the thing. Velocities are exchanged. Second case, case 2. If we are considering the perfectly elastic collision with E equals to 1 and mass let's say m1 is very very larger than m2, very very larger than m2, then it will, body 1 will rebounds with same velocity, rebounds with same velocity. Okay, so let us consider here, let's say this is a ball and this is the earth, two body we are considering. Okay, so earth is our first body, let's say, and ball is our second body, let's say. So this will be the mass m1, this will be the mass m2. So m1 is larger than the m2, larger than the m2. Okay, so if you will drop this ball from here, you will drop this ball from here to here, let's say it is dropped by height, let's say h1. Okay, तो जब ये इधर से इधर तक गिरकर आएगा, then what will happen, it will come like this and hit the ground, so just before hitting the ground, let's say its initial velocity is u2, before hitting the ground, just before hitting the ground, its initial velocity is u2. And what will be the u1 for first body? Earth is at rest, so u1 will be 0. Simply, yes or no? You can write here also. And u2 will be how much? It is falling from the h height, so it will be root 2gh. Yes or no? u2 will be, if it is fall from the rest, it will be root 2gh1. Initially it was, let's say, here at rest, release from rest. So u2 will be this much, u1 will be 0. What will happen after that? This ball will now, this is the second body, so second body will have now, let's say, final velocity v2, and here what will be the final velocity of earth? v1, again equal to 0, because earth is very large, so there will be no change in the velocity of the earth, so what will be v2? That is our aim. Here we have to find the v2. So apply here first equation, linear momentum conservation equation, m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. Okay, m2 v2. First of all, u1 is 0 and v1 is 0. Earth was initially at rest and finally earth will remain in rest because it is very large. By the ball it will negligibly disturbed. Okay, negligibly disturbed. So from here m2 u2 will be equal to m2 v2. Simple. It will cancel out. Hence the v2 will have equal to u2. So actually it will rebounce with the same velocity u2 whatever it was having initially before strike. So here it is proved that it will rebounce with same velocity. So how much height it will travel now? So it will go up by same height. So your h2 will be equal to h1. Okay, h2 equal to h1. So this is E equal to 1 case, perfectly elastic collision. So for perfectly elastic collision, it will come down and again go up to same height. But it is ideal case. Okay, कितना भी अच्छा ball elastic हो, after some time the height will decrease. Yes or no? You can also find it by the coefficient of restitution. इससे भी आप solve कर सकते हो. E is 1, it is minus v2 minus v1 over u2 minus u1. यहाँ आपको वेलोसिटी यू हैव टू पुट विद साइन, ओके, सो 1 विल बी इक्वल टू माइनस v2 is upward, you are considering the v2 upward, yes or no, so it will be positive, minus v1 is 0 upon u2 is downward, so it will be negative, u1 is 0, like this, so 1 equal to minus v2 over minus u2, so here also you will get v2 equal to u2. इससे भी आप सॉल्व कर सकते हैं, it will have same velocity of rebounds, v2 will be equal to u2. v2 will be equal to u2, okay. हाँ, सभी को क्लियर हुआ? Everyone clear up to this? Write down जय हिंद, जय हिंद. Write down जय हिंद. ओके ओके, ओके, तो चलिए इसका हम लोगों ने कंसेप्ट पूरा कर लिया आज. टुमारो वी विल सी दी प्रॉब्लम्स ऑन लीनियर मोमेंटम, ओके. सो टुमारो वी विल सी, टुमारो कल क्या होगा क्लास में, प्रॉब्लम्स करेंगे हम लोग, बहुत सारी प्रॉब्लम्स ऑन लीनियर मोमेंटम, इम्पैक्ट एंड कोलिजन, ओके. कल हम लोग क्लास करेंगे, ठीक है. तो आज के लिए इतना बहुत है. जय हिंद, जय भारत. मिलते हैं कल. बाय बाय. बाकी आपके जो फ्रेंड्स हैं जिनको इंजीनियरिंग मैकेनिक्स का नीड है उनके साथ आप शेयर करते रहिए, ठीक है. सो सारे क्लासेस आप शेयर कर सकते हैं इंजीनियरिंग मैकेनिक्स जो पढ़ना चाहते हैं वेरी मच डिटेल. और जो लोग टोम एंड सोम में एडमिशन लेना चाह रहे हैं वो एडमिशन ले सकते हैं. यू कैन एनी डे टेक दी एडमिशन, ओके. जो लाइव क्लास चल रही है वहाँ से आप लाइव ज्वाइन कर लोगे और जो लेक्चर आपको हो गए हैं वो आपको रिकॉर्डेड फॉर्म में मिल जाएंगे. उसकी रिकॉर्डिंग आपको मिल जाएगी रिकॉर्डेड लेक्चर के फॉर्म में, उसको आप कितने भी बार देख सकते हो, ओके. तो अभी भी जो लोग टोम और सोम ज्वाइन करना चाहते हैं यू कैन ज्वाइन दिस, ओके. प्रोसेस अपना ज्वाइन करने का वही है, आपको सिंपली अपने चैनल पर जाना है. यू हैव टू गो ऑन आवर चैनल. चैनल पर आप जाएंगे, चैनल पर जाकर आपको सिंपली करना क्या होगा, देखो चैनल पर जाकर आपको यहाँ सिंपली करना क्या होगा, चैनल पर ये देखो अपना ये होम वीडियो प्लेलिस्ट इस तरीके से है. इसमें कम्युनिटी सेक्शन में जाना है, कम्युनिटी सेक्शन. कम्युनिटी सेक्शन में जाके ये देखो नया कोर्स स्टार्ट होने वाला है, न्यू कोर्स वी विल स्टार्ट मशीन डिजाइन फ्रॉम 1 अक्टूबर, ओके. तो इसका भी फीस 3000 नहीं है, 1500 है. ऑल दी कोर्स अभी स्टार्टिंग में 1500 इज द फीस, ओके. एंड दीज आर द QR कोड. सो ईदर इस QR कोड से और इस QR कोड से यू कैन डू दी पेमेंट ऑफ 1500 फॉर वन कोर्स. इफ यू वांट टू टेक थ्योरी ऑफ मशीन जस्ट मेक दी पेमेंट एंड टेक स्क्रीनशॉट. फिर आप जाओ इस पर थ्योरी ऑफ मशीन कोर्स पर, हेयर इज द लिंक फॉर द फॉर्म. यहाँ फॉर्म पर क्लिक करोगे आप तो आपके सामने ये फॉर्म खुल जाएगा. बस आपको फिर ये फॉर्म फिल करना है. ऑल द डिटेल्स आर गिवन हेयर, ऑल द डिटेल्स रिगार्डिंग द कोर्स आर गिवन हेयर, यू कैन रीड इट एंड यू हैव टू फिल हेयर ईमेल. आपका ईमेल QR कोड यहाँ भी दिया गया है, कोई बात नहीं, यहाँ से भी स्कैन कर सकते हो. अपना नाम, नंबर, ऑलरेडी यू आर स्टूडेंट ऑफ कॉम्ट्रैक्ट तो आईडी एक आपको मिली होगी कॉम्ट्रैक्ट की, वो आप यहाँ फिल कर देंगे. यहाँ अपना ब्रांच फिल कर देंगे जो भी आपकी ब्रांच है. टोम में तो मैकेनिकल ही होगा बस. एंड हेयर दी टारगेट ईयर आप फिल कर देंगे. कॉलेज नेम, अकाउंट नंबर से पेमेंट किया है तो अकाउंट नंबर, और मोबाइल नंबर से पेमेंट किया है किसी ऐप से तो मोबाइल नंबर यहाँ फिल कर दोगे. यहाँ मोबाइल नंबर ही फिल कर दो, कोई दिक्कत नहीं है. इफ़ यू डोंट वांट टू फिल दी अकाउंट नंबर नो इशू. हेयर UPI या ID जो स्क्रीनशॉट लिया उसका आप यहाँ वो कोड यहाँ पे लिख देंगे जो भी आपको मिला होगा, ट्रांजैक्शन किया होगा आपने. यहाँ 1500 फिल कर दो. यहाँ एक इमेज आप अपलोड कर दो, अपना फ़ोटो, ID प्रूफ और स्क्रीनशॉट, करंट सिटी एंड कमेंट, फिर सबमिट कर दो. बस फिर वेट करो थोड़ा, विद इन आपको 4-5-6 आवर और मैक्सिमम 24 आवर के अंदर आपको कॉल जाएगा और आपको सारा प्रोसेस बता दिया जाता है, ठीक है। सो दिस इज हाउ यू कैन ज्वाइन दी एनी पेड कोर्स, ओके। सो दिस इज द प्रोसीजर फॉर योर पेड कोर्सेस। क्लियर एवरीवन? ओके, चलिए फिर एनफ फॉर टुडे, कल मिलते हैं, बाय बाय। हाँ, भारत माता की जय।